Hello, precalculites, and we are back again with another review of basic trigonometry. Today we're going to be reviewing some special right triangles. I call them special triangles, and they're very special because you get the exact length of their sides. There's a lot of times these triangles are used in construction and so on. So let's look at this first example. If you notice this triangle RST here, you'll notice that you have two angles that are equal. And if you remember geometry, you learned that the sides opposite equal angles are themselves equal. So you know that this leg and this leg of this right triangle have to be equal. And you got the 45, 45. So this is called an isosceles triangle, and RS and ST are the legs, and RT is the hypotenuse. Now, what's nice about the 45, 45 is if you forget the special shortcut, you can always find the missing sides with Pythagorean Theorem because you know the legs are equal. So if RS is 1, so is ST because it's an isosceles triangle. And then I can just use the Pythagorean Theorem here to find the length of RT. So I would end up with 1 squared plus 1 squared equaling the length of RT squared. That's 1 plus 1, and then I would take the square root of both sides. So we'd end up with the square root of 2. Now, if RS is 5, similarly, ST is 5. And if I do out the Pythagorean Theorem, just like I did here, I'd have 5 squared plus 5 squared equals RT squared. And when I take the square root of that, I'd have the square root of 50, which is 5 square root of 2. RS being 4, I'd have 4 squared plus 4 squared, which is 16 plus 16, which is 32, which is 16 times 2. So you'd end up with 4 and 4 square root of 2. Do you see the pattern? Got the square root of 2 there for the hypotenuse. So the relationship between them is that the legs are congruent. The relationship of the sides is that the legs are congruent and that the hypotenuse equals the leg times the square root of 2. Alright, so what I like to do is when I see an isosceles triangle, I first label the two legs that are equal. And I also like to put x square root of 2. So leg times the square root of 2, x square root of 2. Because then whatever number I'm given, I set it equal to either x or x square root of 2. Something to keep in mind when we're finding missing sides of triangles, especially these special ones, if you are going from a smaller side to a longer side, you're going to multiply. If you're going from a longer side to a shorter side, you're going to divide. So keep that in mind as you go through these. So this first example, it says find the missing side of a given leg. So if this guy's 10, right away I mark those two legs congruent. So I know that this leg over here is also 10. And I can label this as x, and x square root of 2. So x is going to be 10, and this hypotenuse is going to be 10 square root of 2. If you cannot remember the shortcut, remember you can do 10 squared plus 10 squared equals hypotenuse squared and come up with the right answer. But try to learn the shortcut. It'll save you some time. So since legs are equal, x equals 10. To find the hypotenuse, I just multiply the leg times the square root of 2. Alrighty, let's look at if you give the hypotenuse. Now, think about it. You're going from the hypotenuse to the leg. You're going from a longer side to a shorter side. So you're going to be dividing by something, but the question is what? So I mark the legs congruent, and I like to label them. Even though they've already got variables, I just label them as x squared of 2. And right away you notice 20 is on the same side as x square root of 2. So you set those equal. When you got your number and you got your little expression here, you know those two have to be equal. So if we set those equal, then we divide by square root of 2 to solve that, and we'd end up with 20 over the square root of 2. But of course, we're in precalculus. We can't leave it like that. So we're going to have to get rid of this square root of 2 on the bottom. And the way you do that is called rationalization. So you multiply the top and the bottom by the square root of 2. Square root of 2 times square root of 2, the square roots cancel out because you're in a sense squaring it. So you end up with 10 square root of 2. You got 20 square root of 2 divided by 2. 2 goes into the 20. In order to divide these numbers, they both have to be outside of the radical. You cannot divide the 2 into the 2 that's under the radical, so be careful about that. Alright, since legs are equal, m and n both equal 10 square root of 2. In short, you just have to divide the hypotenuse by 2 to find the length of the legs. And another trick, if you notice, we went from 20 to 10 square root of 2. If you divide the 20 in half and tack on the square root of 2 at the end, it's the same as multiplying by square root of 2 over 2, which is dividing by square root of 2. All right, let's look at our next special case. So this one is a special right triangle. Triangle ABC is what is known as a 30, 60, 90 right triangle. And they wanted you to notice, they took this triangle ABC and they reflected it across that line BC. So they reflected over. And if you remember about reflections, this angle A would be equal to angle D. This little 30 degrees would be equal to this angle here. Length AB would equal BD. And AC would equal CD because of the properties of reflection. So this, since it is a reflection, and you know that these angles are 60, 60, and this whole big angle up here, 30 and 30, makes 60, it's going to be equilateral and equiangular. So the type of figure formed by A, B, and D is an equilateral triangle, so those three sides are equal. So you got AB, if it equals 2, what is AD equal? Well, you know AD has to equal 2. And AC is equal to CD, so it's half as long as the whole thing. So AC is 1. Now then, we've got our right triangle here, don't we? Because we've got AB is 2, we've got AC is 1, so we can find BC using our Pythagorean theorem. So, and it is a leg. So we're going to have AC squared plus BC squared equals AB squared. And 1 squared plus BC squared equals 2 squared. When we solve that out, we end up with BC squared equaling 3, and we root them, root. And so you end up with BC equaling square root of 3. So this one, I like the little trick, 1, 2, square root of 3. It's as easy as 1, 2, square root of 3, 30, 60, 90. So remember though, when you're doing the 1, 2, square root of 3 thing, square root of 3 is smaller than 2. 2 would equal the square root of 4. Square root of 4 would be bigger than the square root of 3. So that should make sense because AB is your hypotenuse, and it's 2. They tell you it's 2 here. So it has to be longer than BC. So if AB is 10, then you know AC is 5, and BC, if you do out the Pythagorean theorem, it'll be set up just like the one we just did, and you'll get square root of 75. That's going to reduce down to 5 square root of 3. You see in that pattern? 1, 2 square root of 3. If AC is 2, so we're going a different tact, what's AB? Well, we're going from a shorter side to a longer side, so we're going to have to double it. And BC would be 2 square root of 3. All right, so this was just supposed to be kind of a discovery lesson on the 30, 60, 90 right triangles. Keep in mind that opposite the 30 degrees is the short leg, opposite the 60 degrees is going to be the long leg. The smaller the angle, the shorter is the opposite side, and so on. And then you've got your hypotenuse, of course, that's opposite the 90-degree angle. So they like to talk about short leg, long leg, and hypotenuse. How are the sides related? Well, the hypotenuse is twice the shorter leg. The long leg is the short leg times the square root of 3. Notice that everything's compared to the short leg. So if you got the short leg, you're home free. The other ones, you'd have to divide to find. So you'd have to divide to find the short leg. I like to do x, 2x, and x square root of 3 when I see my right triangle that I'm trying to find the missing sides for. And what's cool about these special ones is if they give you one side, you automatically can figure out the other two. So let's go ahead on. In general, again, when finding a longer side, multiply. When finding a shorter side, divide. That helps a lot. If we're looking at this one, 30 is right here. So 9 is opposite 30. It's the short leg. So this first example, we're going to do 3 examples. One when they're given the short leg, one when we're given the long leg, and one when we're given the hypotenuse. So you'll know how to do all 3 types. So right away, I label the short leg as x, hypotenuse as 2x, and long leg as x square root of 3. So 1, 2, square root of 3. Everything's related to the short leg, so we're going to multiply to get the other 2. So there's x, there's 2x, and the long leg is x square root of 3. Notice that x equals 9. So that's what's nice. X is 9. So if x is 9, x equals 9 here, then the hypotenuse is going to be 2 times 9, and the long leg is going to be 9 square root of 3. So x equals, the one that was given in the problem, this x equals 9 square root of 3, and your y is going to be 18. You kind of, sometimes you have x on a triangle, and you have to remember that that's a different x. All right, how about this one? They gave you the hypotenuse. Hypotenuse is also pretty easy to find because it is twice as long as your short leg, and you always want to find your short leg first. So I do x, 2x, and x square root of 3. That's my first step. Short leg, hypotenuse, and long leg. I know this, 42 equals 2x. So I can find x right away. Divide by 2, x is 21. So that means that h length is 21, and then my long leg is 21 square root of 3. So there's my answers. All right, last but not least, we've got a 30, 60, 90, and this time they give you the long leg. Long-legged daddy. So again, I like to label x, 2x, x squared root of 3. X goes to the side opposite the 30. 2x is the hypotenuse. He's the long one. He's the longest one. And then the next longest one is the 12, x square root of 3. So right away I notice right here is what's going to be the key to the whole thing. They give me that this is 12, and I know that's x squared root of 2. I'm going from a long leg to a short leg. So I'm going to be dividing. So x square root of 3 equals 12. Divide by the square root of 3. You get 12 over the square root of 3. Rationalize. So we're going to multiply the top and bottom by the square root of 3, so we do not have a square root in the denominator. This turns out to be 12 square root of 3. When you take a square root times itself, it cancels the square root out. So you'd have 12 square root of 3 over 3. 3 can divide into the 12 4 times. So 4 square root of 3 is our x. And notice I color coordinated. It's purple. There's purple. There's purple. There's purple. So I plug that back in. So side A is 4 square root of 3. And side B is going to be 2 times 4 square root of 3, or 8 square root of 3. And that's it. So that's how you find the missing sides of special right triangles. And the two special right triangles are 45, 45, and 30, 60, 90. Remember, in general, going from a short side to a long side, you're making it bigger, multiply. Going from a longer side to a shorter side, divide. So you just have to practice with those. You're going to have a quiz just basically on these special right triangles. Alrighty, we will see you tomorrow.